Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn direct variation. Let's start. Let's learn first what is variation. Variation refers to the relationships between different quantities and variables. For example of a variation is a relationship between two variables wherein one increases as the other increases. Or a relationship between two variables wherein one increases as the other decreases. There are four types of variations. First, direct variation. Second, inverse variation. Third, joint variation. And fourth is combined variation. But in this video, I'll be talking about direct variation. Direct variation is a relationship between two variables wherein as one increases or decreases, the other also increases or decreases proportionately. For example, if you bought an apple, the total cost and the number of apples bought illustrates a direct variation because the total cost increases as the number of apples bought increases, or the total cost decreases as the number of apples bought decreases. So this is an example of direct variation. They have the same direction. If the other variables increases, the other also increases. Or if the other variables is decreases, then the other will also decrease. Constant of variation. This describes the magnitude or strength of the relationship between two quantities. Usually, this is denoted by K. For example, if the cost of 4 apples is 20 pesos, the constant of the variation there is just divide 20 divided by 4 is equal to 5, meaning the price of each apple is 5 pesos. And that 5 pesos or the price of the apple is the constant of variation. Equation of direct variation. It is a mathematical sentence that describes the relationship between two quantities that are directly proportional. The statement y varies directly as x is written as y is equal to kx, where k is the constant of the variation. The keyword is directly, and it is pertaining to direct variation. For example, if y varies directly as x and x is equal to 2 when y is 4, what is the equation of the variation? To find the equation of the variation, we need to transform first the variation statement into a mathematical statement. So we have the statement y varies directly as x, and the translation for that is y is equal to kx. Then substitute the values of x and y to solve for k. We have 4 is equal to k times 2. Divide both sides by 2 so that we can get the value of k. K2 divided by 2 is 1. 1 times k is k. And 4 divided by 2 is 2. Therefore, the value of k is 2. Then, go back to the original equation, which is y is equal to kx, and substitute the value of k, or the constant of the variation. So we have k is equal to 2. So the equation of the variation is y is equal to 2x. Let's try some examples about direct variation. Number 1, if z varies directly as w and z is equal to 18 when w is equal to 6, what is the equation of the variation? To solve this, we need to follow these steps. Number one, translate the variation statement into equation. The statement is if z varies directly as w. The mathematical translation for that is z is equal to kw, where k is the constant of the variation. Second, solve for k using the values z is equal to 18, w is equal to 6. Using the translated equation, we have 18 is equal to k times 6. Then divide both sides by 6 to get the value of k. We have 6 divided by 6 is 1, and 1 times k is k. 18 divided by 6 is 3. Therefore, the value of k, or the constant of the variation, is 3. Next, substitute the value of k to the original equation. Take note that our equation is z is equal to kw. Just substitute the value of k, which is 3. So we have z is equal to 3w. Thus, the equation of the variation is z is equal to 3w. Number 2. If a varies directly as b, and a is equal to 12 when b is equal to 18, find a when b is equal to 15. Here, we're not just going to find the working equation, but we are to find the value of a using the working equation. Here's the solution. First, translate the variation statement into an equation. Statement is A varies directly as B. The translation for that is A is equal to KB, where K is the constant of the variation. Then, solve for K using the given A is equal to 12, B is equal to 18. We have 12 is equal to K times 18. Then divide both sides by 18 to find the value of K. We have 18 divided by 18 is just 1. And 1 times K is K. 12 divided by 18. We are going to reduce this one to lowest term. Divide both numerator and denominator by 6, or their greatest common factor. So 12 divided by 6 is 2, and 18 divided by 6 is 3. Therefore, our constant of the variation is 2/3. Then write the equation of the variation. We have A is equal to KB. Then substitute the value for the constant of the variation. So we have A is equal to 2/3 B. And this is our working equation. Fourth, substitute the value of B, which is equal to 15, to A is equal to 2/3 B to solve for A. This is our working equation, then just substitute the value of B. So we have A is equal to 2/3 times 15. And 2/3 of 15, so we have 15 divided by 3 is 5. And then 5 times 2 is 10. Therefore, the value of A when B is equal to 15 is 10. And now, I'm done with my discussion. It's your turn to answer this individual practice. I want you to answer these two problems here and kindly comment your answers so that I can check if your answers are correct. And that's all for today. Thank you for watching.